morning, good afternoon. Welcome to November's TBC Power Hour. We're excited to present today's topic on site calibrations and local site settings in TBC. Thank you for joining us. Hopefully this will be a productive and informative next hour for you. All right, I am Joe Blecka. I'm the product manager for Trimble Business Center. I'm here in Westminster, Colorado, and there is my email address. With me today and really doing almost all of the work is Adam Tigris, who is part of our QA/QC team, also here in Westminster. Thank you for your preparation, Ms. Adam, and running the show.
Yeah, thanks for having me, Joe. I'm excited to get started. I am Adam. I've been with Trimble here for a few months. I'm working towards my geomatics engineering degree at University of New Brunswick, and I've had some survey experience out in Western Canada, and excited to get started here.
All right, so let's go over today's agenda. We'll be going over a workflow introduction, then followed by the demonstration. That's really the primary focus of this presentation, and then we'll go through a summary, have some questions and answers, tease the December Power Hour session, kind of try to do something a little different for December and the holiday season, and then go over some existing TBC resources. And speaking of something different, we wanted to mix it up a little bit with this session and go through the presentation and kind of not check for knowledge, but kind of check for knowledge, maybe a reward for a check for knowledge for people paying attention. If at the end of the presentation in the QA section, we'll ask a question to the group, and the first person to respond in the questions box in your GoToMeeting will receive a TBC pack, and that includes these lovely items you see in front of us here. A 1 terabyte Trimble hard drive, USB hard drive, a nice little Moleskine Trimble branded notebook, a USB Bluetooth speaker, and then a fancy mug. I can personally attest that this thing works quite well, keeping your beverages hot or cold. And all of this packaged up into a nice TBC, or Trimble branded backpack. Granted, there are a lot of people on the call. We won't just give out one prize to the second correct response to the question. We will send you out a Trimble Business Center From Field to Finish with Confidence t-shirt. So in this season of thanks and giving, we want to show our appreciation with these little tokens and some free swag for everybody here on the call. So pay attention, stick around for an hour, and get your chance to win some cool Trimble branded stuff. Now, that is all well and good, but what we're really here for is the workflow. And Adam, I will turn it over to you. As with past webinars, if you've got any questions, please type them into the questions box. We will answer them as we go along, or if it makes more sense to answer them at the end, we will do that as well. And then, of course, if any questions don't get answered or we don't have time, we'll follow back up with you. We got your email address when you submit the question. So take it away, Adam. And again, everyone, thank you for attending and enjoy.
All right, thanks a lot, Joe, for that. We'll get started here. I have a brief introduction. Obviously, this Power Hour, we're going to talk about what is site calibration and local site settings. Why are these important? When would you use them? And when you should be using them? Just as a quick summary, they're both tools to transform coordinates. They do this in different ways for different functions, though. They're both functions available within TBC as well as Trimble Access, so you might have run into them in Trimble Access or Trimble Business Center already, or maybe both of them. site settings is licensed to base editions of TBC, whereas site calibration is licensed to the intermediate versions. So if you have an intermediate version or above that you're working on, then you should be able to recreate all the workflows we're going through here today. And kind of one last note is this power hour deals with coordinate transformations, and a lot of that has to do with the difference between grid and ground coordinates. And this power hour was actually kind of inspired from one that was done a few months ago. It was done by Mark White, a Trimble representative for us, and he did a really good job. And then there's kind of some questions that stemmed from that regarding site cal and site settings. So I'm going to be talking a lot about this grid versus ground. And if it's not something you're super familiar with, and maybe you missed that previous power hour, I would definitely say go check it out. I will have a brief summary of it in the next slide here, but definitely won't go in depth or as good as details as he did. So keep that in mind. So talk about local site settings first. What local site settings essentially does is you're transforming some grid projection coordinates into ground coordinates. And it does this by applying a scale factor chosen by the user based on the project location and height. So you want to use ground coordinates lots of time when you're surveying. If you're using grid, then you're going to have issues where your ground coordinates are equal to what you can physically measure on the ground. So if you have a 100-meter line that you survey, if you do that in ground, it could be a little bit shorter or longer than what the ground distance is. So obviously that can have some implications if you're doing construction with prefabricated parts. You know, they're obviously probably going to be designed with real-world distances in mind. If you're doing cadastral applications, such as surveying a boundary, you want that to be 100 meters as it is on the ground, not grid. And if you're working with point cloud data, you could have some control points that are in grid coordinates that you'd want to convert to ground, as most terrestrial point cloud scanning works with ground coordinates. So I do have a little diagram here of kind of the relationship between these grid and ground and the different surfaces that you use in surveying. So this first curved surface, number 6, is the ellipsoid. It's kind of the mathematical model of the Earth where lots of our global coordinates stem from. The problem with that is it's all in latitudes and longitudes, so it can be very difficult to do any of the Cartesian math we're used to. So we flatten it out into this grid surface, which is number 2. And when we flatten that out, there's a distortion, and that's the result of that is a scaling error between these. So you'll have areas where you'll be scaling distances up or down to go from the grid to the ellipsoid. And so that scale factor is called the grid scale factor, or the projection scale factor. You might have heard that. And the final surface is the ground surface. So this is what we're physically measuring on here. And that has a relationship to the grid plane through another scale factor, which is a result of the elevation, the difference. So you can see here in the diagram we have a ground distance, number 3, and a grid distance, number 4, where grid distance is shorter. This is just one scenario. It's not always the case. Your ground distance can be shorter than your grid distance. It really depends on where these surfaces lie within reference to each other. Again, this is just a brief overview, so there's definitely some things I didn't cover. And I definitely implore you to look at that previous power hour if you haven't already.
Yeah, and that was back in July, grid and ground, working with grid and ground in TBC. That recording is available on the Geospatial Power Hour website.
So kind of the final goal with our local site settings is to create a scale factor within our project that, when applied, will make our grid distance equal to our ground distance, as shown in this diagram here, distances 4 and 3. One final thing, local site settings can be used with total station or GNSS coordinates, as long as they have a projection applied which would be like state plane coordinates or UTM or any other type of projection used throughout the world. I'm just kind of used to the North American ones, but there are obviously lots out there. So site calibration is a mathematical transformation of GNSS points. You're going to create a relationship between these ellipsoidal coordinates, which are lat and longs coming from GNSS, and some x and y, or grid coordinates, as TBC calls it. I said x and y here just to kind of differentiate from grid a bit, even though I'm probably going to say grid during the PowerPoint presentation. Because just kind of going back to our previous discussion, you might differentiate between grid and ground, but in this case, when Trimble Business Center sees grid, that we'll see those could be in ground coordinates too. So as long as they're basically coordinates that are in a northern easting x, y, or grid and ground form, then you can create that relationship. That relationship is done by setting up your GNSS and doing RTK surveying in the field. You would take observations to coordinates that you might have coordinates for at the time, or you might get them later. But the main thing is you don't have the proper coordinate system in place, or you don't have all the information to completely tie into that coordinate system. So we're going to take our observed coordinates from the field and pair those with those XY known coordinates to create our site calibration. This is going to create a new coordinate system that we can work in, and everything's going to tie into those known points and that known coordinate system. So kind of when you would use this, and there's kind of two main scenarios that I see and that we're going to go through today. The first one would be kind of where you have an arbitrary local site system. That might be where you get out to a construction site and a previous contractor or maybe someone else in your company has created their own coordinate system where they just dropped a nail somewhere and called that 1000 northern easting. And they might have set north to some totally different orientation that could not even be close to north. So that'd be a case where you would come in and you would just start taking observations there, and you'd have to use those known coordinate systems, those known control points to create a new coordinate system or recreate the previous one. There's also a case used where you're set up your base with just a local here position. Might not be that good quality. You could be floating around a couple meters, but you are working in some sort of projection, for example, again, state plane or UTM. And then maybe you have a few control points that are in that same coordinate system that you can tie into. You're probably not going to tie into them perfectly because, again, your base doesn't have a perfect location. But you can use those known control points and your approximate base coordinate to do a site calibration that way. And site calibration is a 3D transformation, so you'll see as we go through the demo, but we can do just horizontally, just vertically, or a combination thereof. So we'll move into the demonstration now. I will be using TBC version 4.0, which is our latest release, and I'll be using the advanced edition. As I said earlier, local site settings, licensed to base versions, and site calibration to intermediate versions. I don't think I'll be using anything here that'll be kind of exclusive to the advanced edition, but we'll try and let you know if we do. So we'll open up a new TBC project, and we'll bring in some data. This is a fairly simple and standard job here. We have a base point of 400, and we just went out and we we tagged in about half a dozen points. This job is it's in a state plane coordinate system, so we have a projection. This is Utah Central, as you can see, the project settings and the coordinate system.
Hey Adam, how did you get to project setting?
Just up here in the top left, we have our project settings button, and then we're down and looking at the coordinate systems.
Thank you.
So what we want to do first is we'll work through some local site settings, and we can see in the bottom right corner here, TBC says we're in a grid system, which makes sense as we have this projection applied. If we go into our local site options in our project settings, we'll see that currently we don't have a project location. That's something we're going to have to specify real soon here. There is a project hiding here, and that comes from when this job was created in Trimble Access. That's something that Trimble Access forces you to do, and I believe that's just so it can do reductions for total station observations.
It's also used in two-dimensional COGO computations as well.
Right. We can see here, use ground coordinates. We're not doing that right now, and that's something we'll work towards right now. So we'll be done in project settings for now here, and we'll go into our survey tab, over into this network tab, and we'll open up our local site settings. Actually, before we get to that, I want to do some inversing here. So still in the survey tab, we have our measure command, and we'll inverse. So I just want to check between 2 points we have in this project, kind of going all the way across, 1,000 to 1,002. And we can see some distances here in the inverse panel. We have a grid distance that's 284.057 and a ground distance of 284.144. So this is kind of like if you go back to one of the first slides there, where we have that difference in distance between our grid and ground. You know, for lots of survey applications, this isn't ideal. So we're going to set up TBC so that this ground distance is going to be equal to the grid distance in the plan. I'll close that, and I'll actually just do one more thing. I'll just draw a line in here, and we'll give it a bearing of north and a distance of 100. Close that command. We'll open up our inverse again, and we'll just confirm here. We have a grid distance of 100, which is what we drew, and we actually don't have a ground distance. So the reason that doesn't show up right now is because if we look at this line, look at the properties, you'll see it doesn't have elevation. TBC won't be able to calculate ground distance if an object doesn't have an elevation, and that's due to that scale factor I was talking about earlier. It needs that relationship between the ellipsoid and the ground surface. It needs some elevation or height. So we'll add an elevation there. I just picked our base 400 just to kind of keep it the same area. And now if we go back into our inverse, now we have our grid distance of 100 again and a ground distance of 100.03. So this kind of brings back to the scenario I was talking about earlier, where if you laid this out for some sort of construction purposes and you did it in grid, then everything looks like it's a nice 100 meters. But if you went out in the field, you'd actually be 3 centimeters too long. So, you know, that's something you probably want to avoid. It's not huge in this case, but it can definitely get to be a lot bigger differences in bigger jobs. And if you have more elevation differences, we'll talk about that later, that can really affect it. So we'll jump back into our local site settings here, again under the survey tab. And we have 3 main components of the local site settings. We have the project location, ground coordinates, and coordinate display. Under this project location, there's a drop down here for grid, local, and global. So this is if you're manually inputting coordinates, if you're taking a project location from another source, like maybe a plan set that they want you to use, then you can type it in a multitude of ways. For this project, we're just going to be selecting a point for our project. And you want to pick something that's fairly central to your project and with a fairly average elevation. So we could just pick point 400 and use that for our easting, northing, and elevation. One thing you might want to do, though, if you have a fairly large project, is you might want to create an average point. You can do that under the COGO section. This command here, create average. And you can select all your points within the project. So select all of them. You can select add. It has all your data selected here, but this command is smart enough to know that you just want points. So right now this is taking every single point in your project. We'll give it a point ID of 998. And we can compute that. And we see we now have this point created in the center of our project, and it's going to have an average height of all those points. Alternatively, if you have a project where it might be kind of skewed to having a whole bunch of points on one side and not the other, then you can just choose the points to add. We'll clear our selection. So you might just kind of want to do like a four corners thing. So I'll select point 1002. I'm holding down the control key to select multiple points. We'll go 1003, 101, and 102. So we can add those. And you see we get a different average point there, different elevation. So in local site settings, like I said, it's pretty important to pick a point in the middle of your project with a kind of an average height. I'll show that in a second, how that can change your project. But for now, we'll just kind of actually undo these points we created just to clean up the project a bit. And we'll just stick with our point 400 for our project location. You can go back into your drop down here, and you can toggle between local and global. It's not going to affect a whole lot. It's just kind of a display at this point. Again, those are just for if you're typing something in. So we'll move on to our next section here, which is the ground coordinates. Basically, the reason you use this command. So we do want to use ground coordinates. And from there, we get kind of two options. We have an editable text box we can use here. So this would be like if you're working on a project where it gives you a ground scale factor, then you can manually type it in if that's something you already know. I think most cases, and what we're going to do here is we're going to let TBC compute the ground scale factor from the project location. So you can see as soon as I click that, this grayed out so you can't change it anymore, and it automatically computed the scale factor for us. You'll note in the text here it says it's computing the ground scale factor from the project location. So again, that's just the information we entered up here. So you really want to make sure that's right and makes sense. The last thing you have down here is the coordinate display, and this is very optional. It's just if you want to create kind of a new grouping of coordinates for these ground coordinates that you're creating. If you want to offset them maybe 10,000 meters one direction, just so they don't get confused with grid coordinates, or if you have some state plane coordinates that are usually, you're in the 200,000s here, or I guess that's even 2 millions, you might want to truncate the first couple digits, so you could do that. We're not going to do it for that. So we'll hit OK here. And the first thing you might notice is in this bottom right corner where it used to say ground, where it used to say grid, it now says ground. You can click on that and it will open up our project settings. And we can see here that our project location has latitude and longitude filled in. This comes from the project location we just specified in the previous command. And we are using ground coordinates now, and there's a scale factor in there. We didn't have any false easting or northing, so let's just set it 0. So now we'll inverse, kind of check those same points we did before, between 1000 and 1002. And we can see our grid distance, 284.144, and that matches our ground distance, 284.144. I'll check my line here. And you see the grid distance is still 100, but now that equals the ground distance of 100. So what that kind of says here is that any line work you create in the project, that will be scaled along with all your points when you do a local site settings. I kind of said earlier, mentioned a couple times, that the project location and the elevation are very important. Let's do a quick demo here. If maybe you entered the wrong elevation and we had 1432 in here, we'll just get rid of the 1 and we'll call it to 432587. We'll refresh our ground coordinates and we'll get to compute a new scale factor. Got a really good memory. It was something like 1.0003, and now we're at 1.0015. So we'll use this local site settings, and we'll do those inverses again, and we'll see how that changed. So now our 100-meter line, still 100 meters in grid, but it's equal to 100.016. So we are closer than we were before with having absolutely no site calibration, or sorry, site settings. They do sound kind of similar. But you can see how it can make a pretty big effect. You might have jobs where you just have a very large elevation change. You know, it could be a large area, it could be dealing with hundreds of feet, and you might need to kind of break it up into sections to do local site settings if you want to work in ground. It kind of really depends on what your tolerance is, though. There's really no hard set rules that we could give you, but it's something you should definitely pay attention to. So we'll just go back and we'll put our site settings to what they were before, as we had 1.003. And one final thing I want to do is we have some control points for this job. We have them in a CSV. I look at that, it's just 3 points, and they're organized northern, eastern elevation code. So we'll drag these into TBC. One thing to note is that I know these are grid coordinates. The metadata for this file obviously isn't very good, but that's something that kind of a user needs to be aware. And we're still in ground. So when we import these coordinates, we can look at the properties of them, and we compare them to what we just imported. You can see our northern here, 2202.918.059. is the same in here, 220.2918.059. So TBC has no way to recognize that these are grid coordinates, and when it imports into a ground system, it's not going to try and transform them or anything. So you have to be careful importing any points into your job after you've done something like a local site settings, because that's not going to transfer over.
It also shows the benefit of working with the actual raw data from the field. You are able to transform that job file that Adam has done. And those coordinates, they're not just coordinates, they're the actual observations. And as the observations change based on the coordinate system settings, be able to be transformed.
Yeah, exactly, Joe. So I just did some undo on our project here so that we're back in a grid system. I'll import our CSV again. And we're using point northern eastern elevation code. We will import. Now for local site settings, use your same 0.400 for northern eastern and elevation. Ground coordinates, compute. Okay. And now if we look at our point number 1, we'll see that we do in fact have a difference. So now the coordinates that we imported and we did the site calc or the site settings after importing, we now have grid coordinates. There's a difference here. We were at 059 before, now we're 057, 693 to 689. So not a huge difference, but again, bigger projects, spanning more elevation, that can be a lot more of a factor. So move into a new project here. Actually, sorry, I'll stay in the same project. We'll just close it. We won't save it, just to get kind of a fresh slate here. We'll import our same job. And we'll also import those control coordinates that I was using earlier. So, as I said earlier, this was a scenario where we just set our base on 400. We just used a here position. We weren't set up on any known coordinates. But we did have three known control points in the area that we tied into. We have number 8, which we observed as 108. Number 1 down here that we observed as 101. And number 2, which we observed as 102. We can do a quick inverse between these 2 points. And we can see that we have about a 1.6 meter difference between these. So, and that kind of tells me that our base is out by 1.5 meters with that here position, which probably isn't too bad with an instantaneous position. But we want to use our site calibration to fit all these known points to our observations. So we'll open up our site calibration. And we'll see a few settings here. We have horizontal calibration, vertical calibration, and update product definition. As I said earlier, this is a 3D transformation, but you can use it as just a 2D transformation, just doing the horizontal. You can do it as a 1D transformation, just the vertical, or you can do both. I think for most of our demonstration purposes here, we will be using 3D, horizontal and vertical. So under the horizontal calibration kind of heading, we have a function to set the scale factor to 1. So this is something where when we're doing this horizontal calibration, we have 3 transformations we're doing. We're doing a translation, which would be moving the project a delta X and a delta Y value, or north and easting. A rotation, which is rotating around the Z-axis, and a scaling. So the scaling is kind of something you need to consider. If you're in a project like this where our data was collected in a state plane coordinate system and our coordinates are also in the same state plane coordinate system, we wouldn't expect there to be any scaling. So we could actually turn this on, set the scale factor to 1. And what that does is it kind of prevents if we have any bad coordinates. Maybe one of these monuments got really disturbed and they're really out, or maybe when someone gave you the coordinates or when you punched them in, you made an error. If you don't hold that scale factor to 1, then it can kind of scale your observations to fit those incorrect monument locations. So right now, like I said, we'll hold it to 1. We'll do another demonstration where that might not be the case. But for now, we'll leave that turned on, and we'll kind of see how that affects our project in a bit. Under the vertical calibration, we have 2 options. We have a vertical shift and an inclined plane, and vertical shift only. So vertical shift only is kind of what you'd expect. It's just a straight translation in the Z-axis. You're just lifting up or subtracting every point in your job a certain amount of meters. When you use an inclined plane, then you can actually, you'll create some sort of tilted plane. So on one end of your job, you might be raising or lowering by a different amount than the other end. And of course, that plane can be orientated in 3D. So again, this is a tricky one. If you don't, the main thing with this is if you're using the inclined plane, you'll get better residuals, but sometimes that can be false. we'll turn it on inclined plane from here, and you'll hopefully see what I mean. But essentially, it's the same thing as I said with the scale factor, where if you don't have enough points, and if they're not control points, that is, and if they're not good enough quality, if you don't know the source of them, if maybe you haven't done it yourself and just got them from somewhere else, you never know how accurate they could be, then this inclined plane will just kind of fit your survey to those points that could be wrong. We have a geoid model for this job, so that'll just affect our heights, our geoid separation, difference between heights and elevations. And the last thing here we have is update product definition. We're going to leave that checked off, and I'll talk about that in the next kind of demonstration I'll do after this. That'll come into play, but it won't be necessary for this one because we're doing a relatively small translations. We're just dealing with meters. So that's kind of the first part of site calibration, and now we'll move into the point list. So this is where you'll pair those observed point IDs with your known grid points, as they say. But again, like I said earlier, these could also be ground points. In this case, they are a grid coordinate though. So we'll zoom into our first pairing. We have 108 being our observed point and 8 being our known point. I'll do this backwards just so you can kind of see. If I try and select point number 8, which is our grid point, we get an error indicator. It says point with global coordinates required. So I just want to show that real quick, that you don't have to be super worried about making sure you pick the right one, because TBC will give you some warnings and let you know. So you can physically pick these points from the plan view, as we're doing here. You could also just type them in. We do have 3 points in this project, but I just want to just use one just for now. So let's do a quick compute, and we get some results here right away. We see our horizontal scale factor is 1, which is because we held it to 1 in the calibration settings. And you'll notice we don't have much else. We don't have a horizontal rotation. There's no slope of our plane. We do have a vertical shift, and we have no residuals. That's because with just 1 point, all we're doing is a translation. There's nothing for TBC to compare it to. So we can actually apply this, and it will kind of shift our product over. If we look at another point here, we can zoom way in. We can open up our inverse again. And you can see they even brought us to under a centimeter now between our known point and our grid point, which is pretty good, especially for GNSS observations, but that's not really a true site calibration we did. All we did was just a quick little translation. So I just wanted to show that real quick, but now we'll go ahead and add more points. Got to select in here, select 101, and then 1. And our GNSS point is 102. I'll just enter these in, and 2. So now if we compute this, our old calibration will be deleted. That's what we want. It's not very good. We want to do a new one with these extra points. A horizontal scale factor, is still set to 1, as we specified in the settings. Now you see we have a rotation value here that it was able to compute because we have 3 points. Our maximum slope of our plane, we're at 0 because we did a vertical shift only. We do have a vertical shift of negative 1.234, which is kind of a cool number, but just a coincidence. And then down here, we actually have some horizontal and vertical residuals. There's a note here that you can take note of too, that these residuals are your calculated coordinates minus your control coordinates. So we're not taking our initial observations minus the control. These are the new computed ones. As you scroll down, you'll see a kind of a diagram for each one of your points. how far out on the vertical and the horizontal they are, and which direction. So this project, everything, those are very small residuals. Must have had a good surveyor in the field that day. We'll go into our calibration settings and change a few things and see how they change. So we'll let TBC scale our observations. So we'll uncheck that and set the scale factor to 1. And we'll also use the vertical shift with the inclined plane. We'll compute again. And now we can see our horizontal scale factor. We're a little bit under 1. But that hasn't changed our residuals too much. As you can tell, they made them a little bit better. But since this job was all pretty good and everything fit pretty well in the first place, it didn't make a huge difference. But the major thing you'll notice here is that there are no vertical residuals. And that's because to create this vertical inclined plane, the minimum you need is kind of 3 points. So, and we only had 3 points in this project to compare. So when you're dealing with site calibration, it's important to kind of be aware of how many points you need. As we showed initially, you can get away with just 1 point to do a straight horizontal and vertical translation. But again, that's not a very good calibration. If that 1 point is out, then your whole calibration is going to be out. If you have 2 points, then you can do a full horizontal calibration. You can calculate your project rotation and your scale as well as your translation. But again, we have the issue where if one of those points is incorrect, then you don't have any checks. Your rotation is going to be out, your scale could be out, and that's kind of a good reason why we might want to hold that scale to 1 or make sure that it's not too far away from 1. We're getting to 3 points, and when you're doing a horizontal calibration with 3 points, it's a lot better. Now you can actually have a check on the 2 other points you held previously. And I'd say still when you're doing horizontal, you probably want to use at least 4 as a minimum. Obviously, I'm kind of breaking that rule in this job right away. We only had 3 points, so sometimes you do have to live with it.
And it's important to note, and Adam's touched on this a couple of times too, is to know the quality of the coordinates. You know, if you're a one-man or one-woman shop and you do everything, then you'd be a little bit more confident potentially getting away with something like three coordinates instead of 4. However, if you don't know, or if you don't know the source of who did the work in the field, or if this has been something handed down project over project, you don't have a whole lot of confidence, then you probably want to err on the side of more caution and use more points.
Yeah, it's definitely never going to hurt to have as many points as you can. You can always choose to use them for horizontal, vertical only, or just not use them if, when you look at your results, they're out. So yeah, it's pretty critical to keep in mind how many points you have, depending on what type of calibration you're looking for and how good those control points are to start with. So we'll do another quick calibration here. And this is actually coming from the tutorial data. So if you don't know or you haven't used TBC a lot and maybe you haven't gone through tutorials, I could recommend it. You can definitely learn some things in there. I just accessed that from the start page here. Under Learning Aids, we have tutorials. I'll bring you to this web page. You can download all of them, or for this case, we're just using the calibrating site. There's a tutorial in there with a PDF that'll kind of go through it, as well as some data. So we'll just be using the data, and we'll kind of go through a slightly different workflow than they do. So if you check it out, you won't be doing the exact same thing I'm doing. It will be a little different. So we have 2 jobs in there. We have a 2tank.jxl and a 2tank.rtk.jxl. We'll open just this 2tank first. And we'll see in TBC, this dialog comes up for the product definition. It says it's a scale-only project, and we can modify the scale factor. We don't want to do that. What this tells us is this was a total station project. They did scale only, and they set the scale to 1. So that basically means that there's no scaling involved, and any distances they measured will be equal to grid distances, which will be equal to ground distances. So we'll hit OK, leaving that as 1. It's usually good to look at the warnings and errors. There are a lot of warnings here, and that's just because I deleted the scan information and the photogrammetry information from this job. We won't be using it right now. You probably won't have the same problem if you download it from the website. You'll see TBC says we're in a grid system here, even though we're actually in a system where grid equals ground, and that's because it's that scale-only job with a scale factor of 1 that I mentioned earlier. If we do an inverse here, we can see that our grid distance, 136.358, equals our ground distance, 136.358. So TBC doesn't actually recognize that it's a ground job when you import total station data like this, but you as a user can realize that. And we'll open up the second part of this job, which is our RTK observations that we'll be calibrating to this site that we started doing our total station observations on. And you can see they are way far away. We're hundreds of kilometers, basically. We're still in a grid system, but if we look into our project settings again, and we open up the coordinate system, we can see that we are in a projection now. The reason for that it changes is that GNSS observations cannot exist in a scale-only project. It either has to be just a straight WGS84, or there needs to be some sort of projection. So that gets automatically updated. If we go back to our total station work, and we do that same inverse again, we'll see a difference now between our grid and our ground, and that's because we're now applying this projection. So our grid distances won't be equal to our ground. But we're going to calibrate this site, and we want our final result to be in ground. So the first thing we're going to have to do is a local site settings. So we'll go back into that. We'll pick our point. We'll just kind of pick one in the center of all this, and we'll use that for elevation. We'll use our ground coordinates. We'll compute a scale factor, and we won't do any false easting or offsets. We'll hit OK. We'll see that we're in a ground coordinate system again. We'll do a quick check over here, and we can see our grid distance equal to our ground distance. So now we actually want to do a calibration to this site. We'll set the scale factor to 1 here again, even though it'll cause some problems, but I'll just show you what those are. We'll leave our vertical calibration. We'll just do a vertical shift. We don't want to worry about having not enough points and having a tilted plane. So we'll select some points here. I'll just go through this really quick. We have our 101 points with a suffix of _GPS. Will be equal to just 101 for our grid point and kind of our other job location there. So we have 99 GPS and 99, 116 and 116. Let's go through this really quick. If we go back to our other job here, then we can see the same points: 99, 101, 103, 115, etc. So we'll compute this, and we get a warning that our calibration results are exceedingly big. We'll hit OK, and it'll bring them up. And we can see we have these maximum horizontal residuals of 0.119. And the reason for that is because we forced TBC to hold the scale factor of 1. So we'll go back, and we'll uncheck that, and we'll compute it again. And now you can see we're down to 2 centimeters. So the reasons we don't want to hold the horizontal scale factor now is because, remember, this was done in a grid job, that state plane coordinate system, whereas this was done in essentially a ground job with a scale factor of 1. So this is a case where we actually do want to scale these observations to fit our site over here. So we'll go ahead and apply that. And you'll see that it transforms all our GNSS observations all the way down to here. And now, since we converted all our GNSS observations to ground, and we brought them to this ground job, it would make sense that everything should be, grid and ground should be equal. If you notice here in the bottom right, we're now in this calibrated job. So if I do a quick inverse, we'll see that they are actually not equal. Our grid distance is 0.548, and our ground distance is 0.358. So we're still out by a centimeter there. And the reason for that is, in the site calibration settings, I talked about this update project definition. When you're doing something now where you have, where your GNSS observations might be very far away from the total station, or the coordinate system you're transforming it to. In this case, if we go into our project settings and look at our site calibration, we can see our project origin is still in the 400,000s. So it's significantly far away from where we are. So this is the case where you want to update the project definition. You have 2 points here. You have just creating a new project definition from the first point pair or the mean. As you go with the mean, it doesn't seem like there's any wrong reason to. Usually your site calibration points should surround your site pretty good. So I'll compute that again. Again, I'll delete the old. And you can see it gives us the same residuals. It's not changing anything like that. It's just changing that project location. So now we apply that, and we'll do one final inverse here using the same points. And now we can see finally our grid distance is 136.358, and our ground is 136.358. So we matched our GNSS observations to our total station ground observations. We changed our project location into where we're working, and now we can export this job or this calibration, and whenever we go out in the field, we'll be working in this system. So that's pretty much all I have for demonstration here. We'll jump back into our slideshow. And I just have a quick summary of everything we did. Just site settings, you're transforming between grid and ground coordinates, where site calibration, you're transforming between GNSS coordinates or observations and known grid coordinates. Site settings is strictly a horizontal transformation, where site calibration is a 3D horizontal and vertical. And with site settings, you can use GNSS or total station coordinates as long as they're in projection, whereas site calibration just deals with GNSS observations and known coordinates.
All right. Thank you, Adam. That was a lot of information. This recording and this presentation will be available for download after the fact. I know everyone's itching for our trivia question here, or our knowledge check question to get the free TBC swag. I will ask the question now, and then there's been two primary questions being answered or asked throughout the presentation. So we'll address that. We're running a little short on time, but I've been answering as many as I can here throughout the session. If you don't get to your question, or if you'd like to follow up again, please let me know, and we'll reach out to you if we haven't addressed your question. So for our TBC pack, first person gets it, who gets the answer right. The second person will get that awesome TBC t-shirt. What are the two sets of coordinates that are used for site calibration? So two sets, we're going from blank to blank. I'll let everybody respond now, and instant response, great job. think about that if you will, and I'll talk about the two primary questions that we've gotten. So something that has come up is, why wouldn't you scale your ground coordinates around a 0, 0 coordinate base? This, I guess, is a standard procedure for some projects, for some DOTs, for some MOTs, and the answer to that is you can. However, the further away your project location is from your actual site, the more distortion and inaccuracies you'll be introducing. Adam kind of showed that when he purposely fat-fingered in the project height, and we saw it was a couple of, a couple millimeters available for the 100-meter line?
Yeah, I think that was a centimeter or something.
Centimeters. So it does make a difference. Depending on what you're doing, it could make a huge difference. And TBC would support the requirement, if it is a requirement, to use a 0, 0 project location. You would just type in 0, 0 for your project location. And you can compute your scale factor that way. However, we always do recommend, if you're starting up a project, and especially, and this is a follow-up to a question that Kevin had, on long linear projects, like a roadway, towards the edge of your project, the further and further you get away from your project location, the potential for more and more distortion and tilt errors in the local site transformation. So we'd always recommend picking a centrally located project location for those reasons. And then a question coming in from Vivek. This is a great question. Thank you, sir. Can I use a total station in a job file with a calibrated coordinate system? So absolutely, you can mix GNSS and total station data. To do this, you would kind of do a combination of what Adam has shown. You would import your GNSS data. You would compute your local site based off of that GNSS data in your project location. Then you would import your total station data and complete your site cal from there. So that step of using the local sites first, that would bring your ground plane up to your grid plane. Excuse me, I got that. I knew I was going to reverse that. That would bring your grid plane up to your ground plane.
Could be the other way.
Either way. Yeah, but the actual, the theoretical motion of what is adjusting based on that diagram Adam showed earlier, that ground plane is, or the grid plane is going to be adjusted either up or down depending on your location to ground. And then the grid would then equal ground more or less. You'd bring in your scale factor only project, probably a scale factor of 1 for ground coordinates with total stations, and then do your site cal from there. All right, so keep the questions coming. The correct response to our question, which was what are the two sets of coordinates used for a site calibration, is a combination of either GNSS WGS84 to local grid coordinates. And the first person that had that was Robert Moores. Thank you, sir. We'll be in contact. The second person who had that was Ken Schramm. So thank you, gentlemen. We'll be in contact to get some shipping information from you and send you those packs and your TBC and Trimble swag. Let's go on here real quick. I want to show, go ahead. The next power hour, we're going to do something, hopefully it'll be a little bit fun, a little bit entertaining. I'm going to title this the TBC Team Live. So our guest host, I'll be kind of the moderator, for better or for worse, will be a collection of TBC team members from engineering and marketing. So the way we want to structure this is for you to be able to kind of run the show and submitting your TBC questions ranging from highly technical to subjective via this Google form link, and I'll post this on all of our favorite channels, our Facebook, our TBC community page. But we really want to get your questions. What do you want to talk about? And then based on the questions that come in, we'll bring in the appropriate members from the TBC team to answer them and get to know the team a little bit. So questions ranging from, how do I launch UAS Master from TBC, to getting a little insight on, what does a developer say his hardest or her hardest challenge has been developing new features as we've aggressively expanded the product. Questions of, hey, where did Boris go? I missed that Midwestern accent of his. He'll be around. I think he'll be a large featured presenter here in this. So we'll bring all this together, kind of keep it loose, try to do the video thing again so you can see our ugly mugs, and really get to know us a little bit more, and then also show you the resources that are available to you. We are a group of very dedicated men and women here to build this product. There's a lot that goes into TBC. There's a lot of resources and learning educational tools available to you. So trying to get that out there. We wholeheartedly believe in this product, where we're going, where we've been, and having a little fun here before the holidays. So some of those resources right now available to you, and I pitch this after every one of these sessions, is the TBC Trimble community page or the TBC Facebook page. That community page is really valuable because that's kind of a web forum for questions, for direct access to our developers and our marketing team. We do maintain a very active YouTube video page under the TBC survey channel name. And then these Power Hours, if you haven't viewed this page yet, I'd really encourage you to go there because they're all available for download for you to view. We've been adding the presentation slides here lately, and these are all free resources for you to use. Kind of piggyback on what we've talked about here today, that July 2017 Power Hour with Mark White was very well attended, very well received, and is kind of a great intro to what Adam just talked about here today. And one more slide. If you like what you see and you don't have TBC or you want to learn more, visit our new website. A quick short link is trimble.com/TBC. You can download version 4.00. You can find your Trimble distribution partner to request a free 30-day demo license. And then within the software, really encourage you to use those tutorials. We posted them on the website now for easy access. Check out our YouTube videos or ask the question on the community. We've been a little bit rusty getting our tips of the weeks out, but again, we're really trying to make this product much more accessible to our users. So with that, I think that's all. I want to give a special thanks to Adam and Brian on our QA/QC team. Thank you, Brian. You've been very helpful in developing this. Adam did all the work here. All of the credit goes to him for this. Thank you, sir. And then a special thanks as well to our Marcom team, Mr. Michael Dix here sitting with us. Thank you for putting this all together. So we've got all your responses. Congratulations to our 2 winners, and we'll be in touch. So until next time, see you in a couple weeks, and enjoy using TBC. Thanks, everyone.